Thank you, everybody, for joining us today. This is the panel on considering TCO for edge solutions. My name is Josh Taubenheim. I'll be moderating today. I'm an IoT solution developer and analyst with MachNation. We have a lot of good topics to cover today, and I think we have a lot of good people to cover them. So I'll allow everybody to introduce themselves, starting with Chipalo, I believe.
Sweet. Hey, everyone. I'm Chipalo Street. I lead the product management team for Azure IoT Edge, which is a product that lets you create workloads which can contain high-value AI, target them at edge devices, and then monitor the operation of those workloads remotely from the cloud.
Okay. Dana?
Yeah, I'm Dana Anderson. I head up the North American advisory practice within Cognizant's Industry Plus group, and previously I was vice president of device intelligence at Edge for Schneider. Spent time at Intel and Wind River, so I spent a lot of time on the edge. So can't remember who's next.
On the edge. Okay, Jeff.
Yeah, so I'm Jeff Brown. I'm Senior Sales Director for Advantech in North America for the Industrial IoT division of Advantech. Just quick, Advantech's a 35-plus-year-old company focused on industrial embedded computing, wide portfolio of solutions. And I've been with Advantech for about 15 years. So a lot of history in kind of the industrial embedded compute space and IoT.
Awesome. Thanks, Jeff. Philippe.
Yes, and my name is Philippe Cases. I am the CEO and founder of Topio Networks. I started Topio Networks about 5 years ago, recognizing that the last 20 years have been about connected human to the internet, and the next 30 was about connecting objects. And there is a lot of requirement. We're going to talk about that, what connected objects brings. And so we're going to talk a lot about that today. We're tracking the requirements for infrastructure because we are going to have a lot of infrastructure requirements. We're tracking technologies, edge, wearables, AI, and we're also tracking all the use cases that are associated with the edge. So thank you so much for having me. I'm very honored to be speaking with all of you.
Yeah, all right. Thanks, panel. Love it. Thanks for joining us today. I want to start out with just sort of a broader question for the entire panel, just to sort of kick things off, and we'll see where our thoughts take us. And I do have some pointed questions towards panelists. I want to make sure we get those in. But let's start with this. Thoughts on taking a holistic approach that balances getting started quickly and having a foundation that enables evolution into new use cases. So that holistic approach versus that sort of maybe jazz-like, you can kind of mix things up as you go approach. Thoughts? Anybody can jump in.
Well, I guess I'll take a start. I think one of the key things in this whole space is, I think quick is good. I think there's a balance, right, between quick, doing things too quickly, and then also thinking about them too long that nothing ever gets done. And I think there's been a lot of companies that have been in that stage where the planning has gotten so astronomically long that nothing has ever come out of the planning. So I think for me, a lot of that balance of trying to figure out how to leverage companies like some of the panelists here that have gone down that journey so that you can get into an application or an area that's important to your company in a quick way, but an organized and thoughtful way. I think that's that's one of the keys to kind of getting started off. And you mentioned new use cases. I think there's a lot of new use cases that are based on kind of old use cases. So leveraging the history of these old use cases so you can start in an organized fashion and go down a path that's already been traveled before can really make that journey so much easier. And so leveraging experienced people like the panelists here, I think is really key to that journey.
Yeah, I may pile on and just say agree. Velocity is good, and I'm a big believer in kind of the lean startup approach. So I do think that there's this virtuous circle where you essentially plan something, you roll it out, you learn, and you iterate. One of the things I would emphasize with whatever use case it is to make sure that the business objectives are clear and what success is. So often along the way, And it's a little bit unfortunate because I see a lot of good ideas sort of fall down because they don't get the correct amount of kind of attention and support within organizations because there's a great idea, but it wasn't well grounded in what the business objectives, KPIs are. And so as you go through that startup and you go through that scaling, somebody either hasn't done the math or does not understand what's being done, and then sometimes the right thing doesn't happen.
Yeah, I completely agree. And I think both of the concepts that Jeff and Dana talked about, there's an interplay between both the customer and the vendor of edge solutions. So for example, the customer needs to have a clear view of the problem that they're going to solve to understand what that business value is. We also need to make sure that there's incremental measures of success towards that final goal, because that really allows management to continually buy off on the project, as opposed to letting it get to a point where like, hey, we're waiting for the perfect solution, and then momentum on the project dies. And then finally, as you are building this project, whether it be your POC or a second or third click stop, we really have to comprehensively test it under real world conditions to uncover hidden costs like management, DevOps, operations, security. And so those are really the onus on the customer. But there's also onus on the edge vendors, where we play an important role by like creating documentation that's easy for customers to understand these new technologies, or creating products that actually solve these hard problems. And then when it doesn't immediately solve it in the getting started, right? Because we want to make it very easy to start, but some of these problems are complex and would limit the speed with which we're able to iterate. At least call out additional areas that the customer needs to consider that weren't covered in, say, the quick starts. So to me, it's really interplay both of the customer and the vendor providing these edge technologies.
I agree with that.
I would echo what Jeff, Dana, and Chipalo are saying. I would add a little twist to it, which is it really depends on what the application that you're going at is. So there are today, some killer apps like you're talking about autonomous of robots as one of the killer app. The other would be consumption of videos. That's also another killer app. But from on other industries like energy or oil and gas, it's a lot of small applications that are going to make the value of an edge implementation. And so understanding, as Dana said, right, understanding what is the end goal, what are you trying to do, and then make sure that you identify all the use cases that are going to be implemented leveraging your technology is going to be really important to justify the cost of an edge investment at this point.
Mm-hmm. Yeah, so I wanted to ask this question next, but someone in the Q&A, anonymous, put this in. I kind of want to wrap it into the next question. My question was going to be top requirements for evaluating an edge solution. What should enterprise customers who are looking to buy an edge solution, what should they be looking at? Now, we got a question in the Q&A that says, what is the biggest cost in an edge project? We have seen this as a hardware then services, but wondering what others are experiencing. So let's get your take, panel, on what you should be evaluating and where you're seeing the biggest cost, and maybe where enterprises should be focusing their evaluations on in terms of TCO, right?
Yeah, I'm happy to start again. I think one of the costs that we see is when people they know what they want to do today, but they don't know what they want to do tomorrow. So from a hardware standpoint, if you ripping and replacing to upgrade 2 or 3 years down the road can be more expensive than the solution itself. So that install piece can be very expensive. So taking some time to think about not only what do you want to do today with this application, with this hardware, with this point of focus, but kind of what could be the future, because making sure that you have infrastructure that can support that expansion rather than rip and replace can be a huge cost and a huge burden to the company. And limit the ROI. So, because that's the other thing, sometimes the easiest ROI is quick, the biggest ROI is down the path, but you've got to plan for that, now in terms of your infrastructure. So,
and another thing that's closely related there, like Jeff just talked about ripping and replacing hardware, but software is also a very key component of this, right? Like, and I don't know about your devs, I know my devs never write a bug. We never ever want to update the software that's running on a device. And if you distribute these devices at scale, like, do you have a way to remotely manage these? Are you planning to roll a truck to each one of these devices to update them? If you're rolling a truck, does that technician, he probably is very skilled in some kind of like field service, but they may not be computer scientists who know how to update software. Like, there's a whole side of like the software management as well as the hardware management. And then the other thing that always pops to me is security. There are so many intricacies of security from the hardware required. Like, do you have hardware security modules like TPMs? What type of data are you storing and how are you securing it? What is the liability to my company if there is a security breach, right? Like, not just like the TCO of the edge solution, but like I could lose my company's credibility if my solution is used for ill intent somehow. And so there's tons of those types of things, but hardware management, security are three things that just pop to my mind immediately.
Great points.
Then another cost that is often overlooked is the cost of people. I mean, there is a lot of conversation that have to happen between IT and OT, because most of the OT system, I mean, so you have IT, right, with those, Kubernetes workload that can run across on-premise, at the edge, and in the cloud, and then you have those devices that have been operated for the last 20 years, running on Windows XP and gathering data on Windows XPs. And how do you make those two work together? So both at the technology standpoint, but as well as also at the people standpoint is very important.
Yeah, and piling on to that people expense. So, I would say it's not the hardware. Usually the hardware is pretty well built, unless you don't properly size it, which is a problem. You get people that are kind of short-sighted and they go, well, I could, undersize this and save, a couple $1,000 here and there. And then it turns out that's a very expensive mistake. So, you've got the operational cost, like you say, if you assume that people have proper device management, which you should assume, proper provisioning. So there's a huge expense. I think people grossly underestimate, don't have remote provisioning in place for putting certificates so either they have to pre-provision it at some kind of distribution center and then send it out, or that same thing for the replacement, or they have to send somebody on site to do it, which is expensive. And that initial provisioning piece is massively expensive. It has nothing to do with the cost of the hardware. So those operational aspects, and I do think that just to emphasize what the others have said around the software lifecycle and figuring out who owns what and how that's designed. I've seen so many cases where both the edge infrastructure and then on the cloud side or on the receiving end of that infrastructure versus the application itself gets fatter and fatter over time, and you end up spending a huge amount of time below the value line focusing on just showing up. Maybe in the old days, people wrote their own operating systems. Thankfully, we don't do that anymore generally. But even with a lot of other systems, they tend to kind of homebrew something, and then they don't consider the total cost of the life cycle of the software. So I would say provisioning, device management and software are the biggest expenses.
Right. And that's actually a perfect segue into some of the more pointed questions I want to ask. Jeff, this one is for you. And it's actually kind of piling on to what Dana was alluding to here with total cost of infrastructure and device management. A lot of developers often start with a use case, on a Raspberry Pi, building a POC, and then they find that things break down when they get to scale. What are your recommendations for investing in the right infrastructure for long-term success?
Yeah, that's a great question, and it's something that we have conversations with customers all the time. In fact, we sell a Raspberry Pi industrial kit, and one of our first questions are, why are you starting with Raspberry Pi? We know it's cheap, we know it's easy, but the reality is industrial platforms, they're not as cheap, no doubt, but you can also get them really quick. Like our products, we sell through DigiKey and Mouser, and they're stocked. They can ship them the same day with a credit card. So a lot of people think it's just quicker. It's not. It's not necessarily quicker. The other thing that they're missing out on, and it kind of goes back to my first point in terms of leveraging, having a discussion about what are you trying to do, and do we have an industrial platform that could help you start that testing quickly? It's going to be a couple $100 more, I'm not going to lie, but if you develop on that and move forward, your ability to scale is going to be so much quicker, because a Raspberry Pi is ARM based. Maybe you need some more horsepower. Now you got to switch that to an x86, and that's a whole nother effort. So you've proven it out, but it's kind of like you're starting over almost, right? I've proven this works, but now I got to start over and figure out how I'm going to scale that. Well, if you do that in an industrial platform from the beginning, that whole piece is gone. And you have companies like us that can help you with that journey. We can help you get to scale much quicker, because again, we have partners like ZEDEDA that we can bring into that conversation, into that story. So when we're having that development discussion in terms of what's important in the hardware, what are you looking for? What's your temperature range? Because sometimes it might be, hey, this is a commercial application. A Raspberry Pi might be perfect. In fact, I'm not going to compete with that. So if that's the perfect for your application, I'll tell you. It's usually not, but it is sometimes if it's a very consumer-based type application. But if this is ultimately going to go into a piece of mining equipment or even an unvented kind of ventilated space, this is infrastructure that's got to be around for 10 years. Those are all things that I would really question whether a Raspberry Pi is the right choice for that. So I would say just get out there, have discussions before you go down that path, because the time and quickness to that might be completely, you might go off the rails just because, again, you have to start all over again. So that'd be my piece of advice there.
So that's kind of like use case based, right? There's no single, 1, 2, 3 thing you can do. It kind of depends, right?
Yeah, and when customers come to us, I'm asking typical questions, right? In terms of what's your environment? Do you have space requirements? Do you have a cost requirement besides as cheap as possible, right? That's not a cost requirement.
Yeah.
But do you have a preference for ARM, ARM versus x86? What's your I/O requirements? Some of these, this is a simple conversation. This is a conversation you can have in 20 minutes that can help kind of figure out where you need to go. Again, leveraging that experience to kind of have that discussion before you just kind of dive in and try something out, I think can save you a lot of time on the back end.
And I bet it depends is going to be a recurring theme throughout this panel, right? Because given how overloaded Edge is, it goes from these large on-prem Kubernetes clusters down to small MCU type sensors and devices. And what you need for that is going to depend greatly based on your scenario and the type of compute and hardware you need for that.
Yeah. Right. Yeah.
We have a
the
lot
$50 solution that includes cellular, that includes all this I/O and is industrial, by the way, it doesn't exist. So let's start with that. And if you're still open to having a conversation, we can talk some more. So
One thing also to think about is, we are seeing this softwareization of objects, right? Like if you're looking at a car now, it's becoming completely softwareized, and people need to think about more like the object as a whole, right? And the sensors that are going to be in the object, and then making sure that they're building the infrastructure, both software and hardware, that are going to enable a real softwareization of their objects. And if they're able to do that, as Jeff is saying, you can now start thinking about, do I need a Raspberry Pi to power all of that, or do I need an x86? Whatever is needed to actually get the job done, but more at the object level rather than at each sensors.
Yeah, I think it's all been said. I think at the end of the day that there's, I think just to talk about what Chipalo talked about is the definition of edge is as big as a barn door. For folks like us who are on telco, we stick fingers in a blackboard hearing the word edge because it's really on-prem is what most people think of as edge. But yeah, there's such a wide variety, and even some people consider the processing within an IoT device itself as part of the edge as well. And I look at it as, we think about it as a distributed computing network. And what you want to be thinking about is, as you design that distributed computing network, in terms of what makes the most sense to be where, and then really optimize that from an operational perspective, kind of end to end. And there's multiple vectors, and I think that there's kind of checklists you could use to, again, look at where those sharp edges are as you scale, to avoid, these repeating costs, but also high one-time costs of, within this.
I think Dana, you just answered our recent Q&A.
Oh, okay.
The question was, our struggle is that we can design the perfect solution with the best hardware, but the perfect solution, the best hardware, the project becomes unfeasible, or we can go with cheaper hardware but risk project failure. So you were kind of talking about the middle ground. Am I wrong in that? You were kind of talking about where.
Yeah, I mean, I think it's So I think what happens is that people don't think about it as a distributed system. And so you have to decide what you need and where, what the tool for the job. So what tends to happen is that people tend to think of, this is the edge. They tend to think of it in little silos, but we actually look end to end. There are going to be cases where you can go direct to cloud, right? And then you have to sort of analyze, okay, so in what use cases does direct cloud not work? Okay, so we have the issue of, having, enough, in case of communications interruption to provide a persistent environment. So that'd be one thing. Second is data reduction or latency in decision making. So I think thinking about it in those terms, in terms of what you implement, you're going to have a better way of understanding what hardware is needed where and what is the reliability and horsepower needed. And I do think that people tend to either just throw a bunch of hardware at it, not knowing what they're going to use it for, or not, trying to use cheaper hardware and then, paying the price later. But I think you can actually think through what is the design of the system, and again, look at the scaling from a technical, operational, and a financial perspective to determine what is the right fit.
Hey, Josh, I have a little different approach to that.
Sure.
Just in terms of, because I think one of the mistakes I see companies make is they try to select a hardware platform that can do everything. So they have several use cases and they're like, we want to choose one platform. Mm-hmm. The problem is your low-end platforms then get burdened with this high-cost hardware, which then makes them less feasible. So the alternate to that, what I see companies doing is they have like a low, medium, high, or low, high. So you're scaling your hardware to your application space. This application space can accept $1,000 hardware, where this one needs to be $200. So don't force that. Allow yourself to have, if you can have a single software platform that can scale across that on multiple pieces of hardware, that's where big companies that we're working with really, they don't want to have 10 different platforms, but 2 or 3 is something they can manage, especially if it's 2 or 3 platforms that have some longevity so that they don't have to change platforms every 1-2 years.
Exactly. And I want to build on that question with a question for Dana specifically, and then we can all jump in. So that was kind of like what you were just describing, Jeff, that customers tend to like the one vendor approach, right? The turnkey, you can do everything for me kind of. Can you talk about the importance of partnerships and offering a complete solution?
Yeah, so first of all, plus on the small, medium, large. I think that, there's somewhere in between the one size fits all and then not attempting to have any kind of uniformity. But I have long believed in the small, medium, large, and in a lot of, solution set design. That is a good approach. Small often is BOM cost constrained, and/or there's either physical or power constraints. And that means that you've got to make certain decisions around where you can support in that platform and so on and so forth. So you can I think that's a great approach. And then with respect to the ecosystem, the other thing I'll say about that kind of feeds into the partnership is I really think that it's really the software execution environment that ends up being the thing you have to be most careful about, and trying to drive some level of uniformity there within those different classes so that you have the ability to avoid a lot of lifting and shifting in different environments. So I'd say, in all of this and all of IoT and connected products, anybody who isn't leveraging the best of the partnerships is going to be in for a world hurt. The value line is always improving. So working with the likes of my other esteemed panelists, whether it be a cloud edge solution or industrial hardware or a software framework and architecture, absolutely. And I'll say one of that enables that ecosystem is also open standards as well, and open source. So I would say those are really critical ingredients to actually making all that fit together in terms of actually having a rich ecosystem. And ideally, you'll have the ability to have reusable components that you can flex across different parts of the solution with different vendors. But that really drives from an open source, open standards perspective to make sure you can do that. So, and then also just from a curated solution perspective and design capability, I think people don't necessarily have to grow their own software team to do things. They don't need to have their own in-house. There's a lot of service providers, and Cognizant being one that can not only help you develop the solution, but also maintain it as a managed service. And there's a lot of organizations that do that. So that as you look at your TCO, consider that as well in terms of, is this the business you want to be in, or is this something above the value line that we need to do? And there's a lot of opportunity, again, working with respect to the value line and where you're investing time and energy and investing in the places that drive your business.
For sure, and I think the edge vendors again have a big part to play in this, depending on what type of partnership it is, right? Like if it's a solution integrator, then we need to make sure that there are solution integrators who understand our various edge technologies and can build a complete solution for a customer, so that customer has one hand to shake with that solution integrator. If it's similar for an ISV, if that ISV is creating a white labeled product, like the customer just wants to interact with the ISV. But we also need to make sure that our components are reusable in the case where end customers want to create their own solution, and it really becomes the onus becomes on both the edge vendor and the partner to make sure that pieces integrate seamlessly, and you don't get this, oh my God, Microsoft made something or AWS made something, and then the other partner came in and they sort of bolted this thing on, and neither of them work great together. They're selling a value prop that isn't quite delivered because there's these jagged edges. And so depending on where that partnership comes in, I think it's really imperative on the folks in the ecosystem to make sure that that end customer really does have a joyous and seamless solution that they end up with.
One question, Joshua, I have on this one is I'm kind of intrigued by what Microsoft is doing with Percept. Because I truly believe that at the edge on in-device we're going to have the same things that we had with the phones, and that we are going to need some level of certification. So on the phone side, the certification is done by of course Apple and Android, right? And I'm wondering if we're going to see the same type of things where we're going to have somebody somehow that give a level of certification to tell the customers that this entire system works together. So along the line of what Chipalo was saying, which is like how do you guarantee the customers that all those software put together are going to run on that specific device for that specific requirement?
Yeah. Go ahead. Chipalo.
Go ahead, Josh.
No. I was going to ask you. Go ahead.
I was just to say, I think making sure that customers can find devices that work with different technologies is super important. And I'm sure Jeff has some ideas around that in terms of making sure that they're producing devices that customers have confidence work with whatever edge vendor they're working with, and partners know how to use and find those devices as well.
Yeah, we do that. I mean, we personally, it's why we're partnered with ZEDEDA and other companies, Microsoft, of course, to make sure that there's a testing validation that we can do. And what we're trying to do is saying, hey, we've already validated this hardware with this software, with this, cloud vendor. So we know this as a bundled solution is working and implemented in thousands of cases. So we're doing that more and more to try to create, an ease the pain of trying to put all these things together. It's just saying, hey, this is already a validated solution, so your risk is low.
And Jeff, would you be willing to take the risk?
Well, yeah. So, I mean, we don't own the software. But what we can say is, hey, we have customers that have this implemented and deployed. So there's always risk, right? Because as soon as you add an application piece, it's an unknown entity that wasn't, this customer is using a different application, but we know that the implementation is it's deployed, and a lot of those kinks have been worked out. So, I wouldn't say we guarantee it, but we can certainly certainly ease the pain and the comfort level of, hey, at least we know when you're testing this, we know this is going to test out. We know you're going to be able to get something working right away, as opposed to trying to figure out even just how to get some deliverable values out of this. So.
All right. So I want to shift gears a little bit just to make sure we're 4 minutes technically. We can probably go over to let us. But anyway, I have one pointy question for Chipalo. A lot of people ask about how much compute they need at the edge for a given use case, whether that be thin or thick edge. I don't know if you want to go into that sort of a quagmire. What recommendations do you make to customers? And how do you assess those things? What are you looking for when you're making those recommendations?
I mean, I think we've talked or touched on some of these really important issues so far. I mean, to me, right now, at the state of the industry, especially for IoT in such a nascent industry, it comes down to customers thoroughly testing their solution in environments that replicate production so that they can understand what those requirements will be. Going into the future, I think it'd be really great for the industry to come up with things like Philippe was talking about, certifications that give people an idea of what type of device they need. But there's just a lot of work to be done there. Let's just take AI, for example. The hardware requirements for a device doing like NLP, natural language detection or understanding language is very different than video analytics, right? Like in video analytics, you may need some specialized hardware, which increases the bill of material of the device, where you may not need that for natural language detection, depending on the scenario. And so I think it'd be really interesting to see if we can come up with some certifications that sort of benchmark canonical scenarios. But even once you get there, that's just a guide, and it still comes back down to testing in real environments. But I'd be interested to know what other folks think.
You just plugged MachNation for us because we have
there you go.
We have a performance testing tool that does exactly that. Thank you.
There you go.
And I do agree.
I don't even have to shamelessly do it.
It's good.
For me.
How much more?
Yeah. So I mean, we are coming to the end of our time. I want to ask one more question to the panel. We can all discuss, and then I'm sure we're going to get played off like the Oscars pretty soon. Right. And this is kind of a broad question. Use cases with Edge. What are you seeing the most success with, and how are you measuring success? Just because we have such a broad experience here on this panel, it might be interesting to see the different perspectives.
Wow.
I mean, again, to me, it goes down to it depends. Like I can talk about some customers, like we have folks in retail who do dynamic ads or out of stock reduction. And like dynamic ads is about increasing sales. Out of stock reduction is about reducing the sort of maintenance, I guess, of a cooler, right? Like if I'm going to refill a full cooler, I have now wasted a trip. In terms of manufacturing, there's things from like production insights, like how do I understand how different manufacturing plants are producing compared to others, or regulatory compliance, like am I under certain pollutant requirements so that I don't get fined, or even operational efficiency. And I think that sort of touches on one of the questions in the chat about the difference between IT and OT.
Yes.
Who's funding what? How do we define success? That personally I see a lot in manufacturing. And it comes back down to, again, I think the point that Dana made, making sure that we understand the value of this overall solution and getting both IT and OT on board with that, because the OT folks are often super skilled in like mechanical engineering or process engineering, and IT is much more into computer science and like IT systems. And so getting both of those sides on the same page about what's the value that we're producing and understanding the roadblocks on each side and solving them in ways that the solution is still economically viable for the customer is super important to break down those barriers. But completely hear that pain, because we see that very often, the difference between IT and OT.
And I would say that is it's a non-technical problem that I think creates the majority of issues that I see, is actually this misalignment of how people are measured and their KPIs. And that goes for who has the money to do R&D versus operating. So often you have a central group that has the R&D money and they throw it over a fence. Well, then the line of business has to own the operational expense, but there's no incentive for the R&D folks to try to optimize for a lower operating expense. And conversely, So that is like, and that's a organizational dynamics problem. Just to poke in here, we're seeing a ton of, I mean, it's all about automation, and increasing intelligence at the edge. So how do we increase the level of decision support closer and with less people in the loop in terms of being able to drive operational excellence? We see that a ton in manufacturing and pharma, and like you say, even in like retail, where what used to be a person with a clipboard or somebody looking at a dashboard is now driven by a machine learning algorithm, and or decisions are being made to drive more automation and a higher degree of efficiency, not only in what you're doing but the people to do that. So that's kind of the patterns.
Yeah, Jeff.
Yeah, I would agree.
Come in here quick. Yeah.
Yeah, I would agree with that. I just think there's a lot of applications. There's a lot of applications out there where there's a lot of data, but the data, nothing's happening with the data. So by adding edge to that, you can actually do something meaningful rather than just report out. Like smart building is an area that we're starting to see a lot of activity in. I mean, a building has a lot of data. These archaic systems actually contain a lot of data, but nothing is done with that data. So by harnessing that data, you can do more than just report out. You can actually take action on it. You can report out in a much more meaningful way. You can, affect safety and comfort as well as energy savings. So there's, it's usually the key on all of this usually isn't one thing, it's multiple things. The more values you have, the more valuable it is to customer and the companies that are providing it. So I think that's one of the things that we're seeing both in smart building and in general, anything around AI in terms of providing intelligence to that data is off the charts right now.
Philippe, do you have anything now before we?
Well, just like the use case we're seeing, right? So we're seeing three use cases. So as Dana was saying, standardization, right? So mostly standardization when the environment you're working with is going to be disconnected a lot. So like for instance, in boats and on the maritime area where you're not connected to the cloud all the time, you want to have a standard infrastructure that works well when it's connected back. So that's one use case. And then of course the intelligent enterprise, so everything around AI, right? Smart objects, smart machines, smart factories is going to be about is a ground for edge. And then the last thing is around data. So the size of data or of the amount of data that is being created, like so videos or data sovereignty, and the last thing being latency, right? Those are the three use cases, right? So data, standardization, and intelligence.
Awesome. So I think we're over time, right? Did we go to 3:35? Anyway, we're there. So I don't want to take any time away from other panels. So I want to thank all of our panelists, our viewers, and ZEDEDA for hosting today. Thank you guys. I think it's been a great conversation. I think it was helpful for not only me, but people who are watching us today. Hopefully for you as well.